Okay, welcome back to the reading. Gosh, I needed a day to process all that we just read through all of that chemistry stuff. I was a little bit mind-boggled. How about you? So, Biology of Kundalini, we are in page 134. We read Protecting Glutamate Receptors. We did that at the end of the last reading. So now, 135, we are at Neurotransmitters. So Jana Dixon, we're getting deep in the book. We are into the brain now. We were in the enteric brain, and we're going right to the neurotransmitters now, which are both in the brain here and in the brain and the gut. In the body, there are at least 50 known neurotransmitters, which convey a rich selection of possible messages between neurons. And many of these neurotransmitters have over a dozen types of receptors. Imagine that. Remember, as we're listening, our consciousness is going to this part of ourself. Neurotransmitters, the brain's messenger molecules, come in two forms, monoamines and neuropeptides. So here comes these little messengers, the monoamines and the neuropeptides, and these are going to send messages between neurons, all right? So number one, small molecule neurotransmitters. The key monoamines are serotonin, dopamine, norepinephrine, and GABA, okay? The monoamines. Serotonin is made of the amino acid tryptophan. It calms, elevates pain threshold, promotes sleep and the feeling of well-being, and reduces aggression and compulsive behavior. So this is a calming element. We might note, or someone might diagnose, that there's low serotonin in the body, in the brain, if you're not feeling calm a lot, if your pain threshold is really low, if you just don't feel well all the time, or you're feeling aggressive, that can be the serotonin levels. And of course, lots of things can make serotonin levels go up or down. So it's hard to really just focus on that one point. That's one thing allopathic medicine, I think, doesn't do a good job, as being very holistic, looking at the whole picture and how everything plays together. So let's keep looking. Dopamine is made from the amino acids of phenylalanine and tyrosine. It increases feelings of well-being, alertness, sexual excitement, and aggression, and reduces compulsive behavior. So again, you might not have a lot of dopamine going on if you aren't feeling any of those things. And then norepinephrine is made from dopamine, and it also increases well-being and reduces compulsivity. So someone who's exhibiting obsessive compulsive behavior is probably really low in all of these, okay? So all of these monoamines would be being affected if someone had a compulsive problem. Okay, so then next we have neuropeptides. Amino acids made in cell body and transported to synaptic terminals. They share opiate receptors and regulate pain, analgesics, and pleasure. Neuropeptides are manufactured in the endoplasmic reticulum and are called opiate peptides because they behave in the brain like opiates, such as morphine. So our body creates its own sort of morphine, right? The functions include regulating immune responses. That's one part of its job. Raising pain threshold, stimulating feelings of well-being, regulating sexual activity, promoting emotional balance, and enhancing learning. So that's all part of this opiates level, this natural, these natural opiates that our body creates, as well as reducing compulsive behavior. So again, if we're having too much compulsivity, then also we're not stimulating those opiate receptor sites. So this is where people might turn to an opioid, like a medication, a prescription, though those can be addictive, because then our body stops producing when we're getting from outside. And so rather than just helping our body increase its own natural opioids, taking from the outside, though on slim occasions where it could be helpful for an additional analgesic effect. Even like California poppies, which is, you can get that in tincture form, just in a health food store, that can have that gentle opioid stimulation. Okay, so there are 3 groups of neuropeptides: the endorphins, the enkephalins, which we spoke about, I think it was in the last video or the one, and then the dynorphins and substance P for pain. So the thing to keep in mind is that excessive use of the on-switch neurotransmitters burns out the off-switch neurotransmitters. So if you keep flipping the switch on, ding, 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 it's saying you're going to burn off the ones that can lower it. So then you're just always in this hyper. So while peaking, Kundalini peaking, we are so neurohormonally pumped up that we do not actually feel the true consequences of the free radical damage until after hormones and neurotransmitters run out. So you don't realize like how hard you're pumping your system in a peak, is what she's saying, until after the fact. And then you might feel it really strong in the burnout. When one is pumped up on spirit, you simply can't imagine that burnout and damage will occur because you feel so good. It's apparent that Kundalini cycles through various nerve receptor systems at different times, reflecting both lunar and seasonal rhythms. During the peak, it is probably focused more on norepinephrine nerves, moving first through the limbic system and then through the norepinephrine net that traces through the cortex. Epinephrine, or adrenaline, and the closely related norepinephrines are the chief neurotransmitters at the postganglion terminations of the sympathetic nerves. So norepinephrine is made from dopamine, which in turn is derived from the amino acids phenylalanine and tyrosine. It includes feelings of well-being, alertness, sexual excitement, and aggression, and reduces compulsive behavior, as we just read. So when it moves through the digestive system, it's probably focused on the serotonin. When in a collapse phase, like a die-off or exhaustion, then GABA, acetylcholine, and serotonin would be more prominent during the parasympathetic dominant phase. So when you're feeling like the crash, right? GABA is the most common inhibitory transmitter in 1/3 of all synapses, okay? So 1/3 of all synapses contain GABA as an inhibitory transmitter. And then acetylcholine inhibits the heart via the vagus nerve. Opiate and endocannabinoid receptors and nerve centers are highly active during all Kundalini activity, even in the exhaustion phase. Acetylcholine is generally associated with the parasympathetic effects. However, it is thought that acetylcholine is probably the chief neurotransmitter for the preganglionic fibers of both systems. Okay, so the opioid and the endocannabinoid receptors, which you have endocannabinoid receptors on everything, okay? And most people actually don't feed those endocannabinoid receptors, which is a big part of the cannabis movement, is helping to educate on that. They're highly active during Kundalini, and they do contribute to a feeling of well-being and reduced compulsivity and just like a general good feeling that can help the body to assimilate some of these higher frequencies. Like, it's good to feel good when you're getting blasted with spirit and your body's going through metamorphosis, right? Contenders for the neuroexcitatory substances involved in Kundalini include the primary excitatory neurotransmitter glutamate in combination with nitric oxide and histamine, prostaglandins, even the body's fuel molecule ATP. When ATP is split apart, a great deal of energy is released to power the cell. This involves the conversion of ATP into its step-down product, cAMP. Then cAMP activates a protein called kinase, which makes the neuron membrane more excitable. Thus, the whole neuron becomes less inhibited and more easily turned on by neurotransmitters fitting onto these receptor sites. So the neuron is maybe like, no, I don't know about, that, but Kundalini is where we're like, yeah, what? So this is saying like right on that neuron that the ATP, which is releasing energy, turns into the C-camp, which activates a protein that makes the neural membrane kind of open up and allow these opioid, endocannabinoid sort of substances to come in and like allow the body to relax and open, which is what needs to happen during the awakening process, is a surrender. Each person is different, of course, and will exhibit either dopamine, serotonin, GABA, or acetylcholine dominance. And so the ability to withstand a Kundalini awakening differs, as does their experience of the awakening itself. So I love it how it's very personalized, like probably whichever one of these neurotransmitters maybe you have familiarity with or you don't have familiarity with could be interesting. Like from your youth, because your body's going to use, as we've read earlier in the book, whatever's best for you, whatever thinking, emotional response, cues that are going to best fit the awakening that will suit you, right? So same with the neurotransmitters, which one might help you to surrender more, help you to open up into the experience is going to be a personal thing, which also means that your awakening experience is very personal, just like what it means to you, what kind of person you are, how do you interpret things like this? Are you musically inspired? Are you poetically inspired? Would you take that energy and turn it into something? Would you curl it in on yourself? Would you use it to negative self-talk yourself? Would you use it to create a masterpiece? Would you, like push it out into the world and make something happen for the world? Like, what is your tendency? Which also I think is your soul purpose, your dharma, like the imprint of your divine soul is going to also choose which neurotransmitters are going to be appropriate, like which ones are going to relax you, this particular soul essence, into the stream of consciousness that wants to unveil for you your particular genius, the groove that you are. There are infinite factors involved in how readily we will be depleted of neurochemicals, hormones, and other body-mind resources during the exhaustion phase. Season, sunlight hours, emotional resourcefulness, heredity, trauma history, infancy conditioning. Those are part of what we were just talking about. Diet, supplement, antioxidants, your emotional processing ability, life circumstances, social community, intimate companionship or not, or bumpy one, life purpose, vocation, education level, urban or rural, latitude, exercise, are you sedentary? What are your life habits, your samskaras? Like all these things are going to influence what neurotransmitters you need and how much of each. It's like your own special cocktail and what that experience is going to be like for you. The effectiveness of our spiritual practice obviously has a profound impact both on the awakening of Kundalini and the rate that resources are depleted. So how you take care of yourself, what you do to stay healthy, what is your spiritual practice, around how you process, that's going to aid you. As things are sped up, you're just going to use the processes that are familiar to you. So if you already have good habits, your awakening process will be smoother, let's say. While meditation makes the awakening of Kundalini more likely to happen, it also eases the passage and reduces depletion crash effect, making the HPA axis less volatile. So how quickly you're going to even back out. It does this by synchronizing neural nets to fire in a more synchronized way. This is what meditation does, kind of like lines everything up, right? and reduces energy wastage. So it gets your body organized, your mind organized, improves nervous efficiency. This is all important as to how fast you can move this energy through your body, right? You have the right neural network. It also stabilizes and amplifies the hormone production of the pituitary gland and reduces the spiking of the sympathetic fight-flight response, which is super important. I mean, you're stimulating here, so that already is bringing you to the witness attitude. But reducing the fight-flight is so critical because that's getting you out of your animal mind. That's what's attached to your ego and what tells the stories that aren't super helpful to you, in the awakening process. She continues, because various brain areas are neurologically enriched by meditation, there is also more prefrontal control over the limbic system. Meditation makes up for some of the deficits we may have in our primary matrix neuron growth. The central functions of norepinephrine are regulation of alertness and of the wakeful sleep cycle, maintenance of our attention, memory and learning, cerebral plasticity, and neuroprotection. Norepinephrine stimulates neural growth, significantly influences neuronal maturation. How about that? Neuronal maturation. I think this is a huge deal. How we can mature our way of thinking. Neuronal maturation. And promotes neuroplasticity and synaptic development during the early stages of fetal and infant development. Norepinephrine, neurotransmitter, is a neuroprotective. When it is depleted, neurons are exposed to debilitating effects of enkephalins and stress hormones released during the fight or flight. Remember, the enkephalins are helping the metamorphosis, so they're helping the breakdown and discarding. But that can be kind of a harsh thing, right? Like if you're really emotionally raw and sensitive, then someone coming and like wiping you up or you being exposed to a lot of people feels really like painful and difficult. So if you don't have enough of this norepinephrine, which is kind of like, you know, to make you feel good hormone, like it's going to be okay, like I got you through this, then you're like exposed. The synapses are exposed to these stress hormones that are going on, and that it doesn't feel as great. So you want your neuroprotectiveness that this norepinephrine offers. In the infant, norepinephrine may destabilize in response to even mild stress, such as a temporary separation from the mother. So some of these baby moments, these early childhood moments, even if we think we had a quite lovely childhood, or our parents are doing the best job they can and not like trying to be traumatic, just normal, what we might consider normal infancy, especially because a parent or both parents might have some trauma of their own that they're still working on, that any way that you're responding that, you know, is even slightly traumatic, let's say, is saying like an infant's neuroplasticity is a lot, and a little bit of stress can, you know, like destabilize this norepinephrine release and like make them a little bit more vulnerable, right? Especially while this stuff is newly developing. So consequently, wildly fluctuating norepinephrine levels can lead to atrophied neural growth and apparent neural networks or neuronal pools. These dysfunctional deprivation and stress-induced aberrant networks are especially pronounced within the amygdala, septal nuclei, and the hippocampus, and can lead to the propensity toward abnormal seizure-like activity such as kindling. So if there is this infant destabilization, is saying that this can sort of like bring a dysfunction in the growth, in the neural growth. which later could lead to a seizure-like activity as the body is trying to make these connections or trying to offer norepinephrine during transformation process. It's like the blanket never was there to soothe, and so it's still not there for these receptors. And so then the stress that's happening in the transformation process, there's no, like, I want to say coddling is usually not a great word, but in this case, we do want that protective field that the norepinephrine provides. And so if there's been like infant stress and those have been disrupted, is saying over a long term, that can lead to this sort of seizure sort of response. Or a seizure-like activity, which is called kindling. Neurons in the CNS, central nervous system, are organized into definite patterns called neuronal pools. Each pool differs from others and has its own role in regulating homeostasis. A neuronal pool may contain thousands or even millions of neurons, okay? One neuronal pool, that's a lot. As well as abnormal growth of nerves, unbalanced neurotransmitter levels can lead to inferior firing patterns. Stress-induced depletion of norepinephrine coupled with excessive secretion of corticosteroid and enkephalins can hyperactivate hippocampal pyramidal neurons and eliminate hippocampal theta and long-term potentiation, thereby interfering with learning and memory. Hippocampal theta state, like that's a deeply relaxing place where a lot of recovery and so forth goes on. So if you have a lot of early stress and there's a depletion of norepinephrine, you can have inferior firing patterns. So you're just not, you're not getting the message through in here. And that can inhibit a lot of areas. But overall, it can be degenerative because not getting into that theta state is disallowing a certain level of recovery to ever happen. So that breakdown is actually continual where it should be being renewed, right? So depletion of neurotransmitters is countered by the use of monoamine oxidase inhibitors. These relieve depression by preventing the enzyme monoamine oxidase, or MAO, from breaking down the neurotransmitter norepinephrine, serotonin, and dopamine in the brain. So you've heard MAO inhibitors, right? Keeping the body from breaking those things down. Of course, normally we have them and then we break them down and release, and then we make more of them and then we break them down. Like we feel them and it's a whole cycle. But if you're having difficulty producing them, then you don't want them to, that's a way to have them not break down and use them longer. As you can imagine, with such exaggerated activation of adrenal, dopamine, cortisol systems, we need to focus on building our serotonin, GABA, and acetylcholine systems, which get burnt out during the hyperphase. So, building up those neurotransmitters. Current research on depression indicates increased deep limbic system activity and shutdown in the prefrontal cortex, especially on the left side. In depression, the most important pathways are those of serotonergic and noradrenergic neurons projecting to the prefrontal cortex from the raphe nucleus and locus coeruleus, these words respectively. Extracellular dopamine in the prefrontal cortex as well as in the other cortexes may depend on noradrenaline rather than dopamine innervation and activity. High dopamine is involved in 4 brain functions of thinking, planning, and problem solving. Gotta have the dopamine. It is antidepressant and produces optimism and confidence. So it's probably a key factor in one's sexual attractiveness and scoring ability, she says. Dopamine has a major role in procreation also, for it keeps one positive, focused, and intent on the job of sex, thus ensuring the continuation of the race. During the heating and peak phase, dopamine is obviously high, along with the sex hormones and the growth hormones. It probably factors into both increased psychic and increased creative genius at this time, not to mention the increased sexual drive. Sufferers from anxiety or depression exhibit increased activity in their hypothalamic pituitary adrenal cortical axis, the HPA. In these disorders, there is a proposed link between noradrenaline and glutamate NMDA receptors. The noradrenaline system has alpha and beta types of adrenergic receptors. There is evidence that chronically depressed people have dysfunctional and atypical noradrenergic systems, particularly the alpha-2 and beta adrenoceptors. It has also been suggested that noradrenaline and norepinephrine is crucial in certain cognitive functions associated with the frontal lobes, particularly the prevention of distractibility by irrelevant stimuli, also called ADD, or schizophrenia. The alpha-2 receptors of the prefrontal cortex appear to be of particular importance in this respect. In those who are depressed, the safety memory mechanism of the prefrontal lobes might not be working well. Chronically overworking the HPA axis or fear response and burning out the catecholamines and adrenals, cortisols, and thyroid, thereby generating depression. I hear just burnout in there. As you read in the Toxic Mind section of book 2, she's telling you, the pilot of the limbic system is the orbital frontal system, especially in the right hemisphere. Without adequate prefrontal limbic control, our emotional regulatory system can become destabilized, which in turn interferes with rational thought and thinking, planning and problem solving. Without a balanced emotional system and a healthy socio-emotional life, we are likely to burn out our HPA axis and become depressed, put on weight, and head toward contracting some sort of degenerative disease. So there is something to be said for needing a balanced socio-emotional life, because there is a certain norepinephrine or noradrenaline release that comes with friendship and camaraderie that is necessary to a healthy system. So if you're experiencing, or you know someone who's been experiencing a lot of homelessness or being on the street or being alone chronically and not like really interacting with other people too much, or at least not with anybody who's of any emotional connectedness or value, then that person is kind of like going into a fight or flight state all the time because they aren't getting, that HPA axis is stressed out basically. And the stress hormones are always pumping, and that norepinephrine is never coming to soothe, so the body is in a stressed state. And eventually, she says, contracting a degenerative disease because the body cannot rejuvenate without the norepinephrine and the opiates and the things that cause us the theta state, those things that send us into the relaxation place. Why I think Yoga Nidra is so good, and I recommend it so highly, and I have Yoga Nidras here in the yoga and meditation playlist for free. I highly recommend doing it whenever and as often as you can, if not by me, by somebody else. I know there's some great 2-hour Yoga Nidras on YouTube that I've found, because it helps to put your body into that relaxed state. And I mean, for anyone who is without a home but has access to the internet, I would highly suggest doing a yoga nidra wherever you are, because it will allow you to regenerate and rejuvenate in a short period of time. 20-minute yoga nidra is an hour of deep regenerative sleep. Okay, we're at 29 minutes and we're at the end of that section. So I'm just going to go ahead and stop there at 138 with Biology of Kundalini by Jana Dixon. Thank you so much for following along. Sorry, I have this funny itchy nose head tonight. Excuse me. Thank you so much for joining me. If you enjoyed this and you find it helpful, and you're feeling the activations, you're feeling the awareness of your own biology of awakening, and you want others to experience that with you, please like, share maybe the first video of this. Maybe if there was something particular in here that stood out, share this video. But I hope you're watching the series and learning and activating this awareness in you, because it will help all of humanity for more of us to know this stuff. So thanks so much, and we'll see you again. Blessings.